Hello my dear students, very good morning to all of you. In today's video lecture, we are going to discuss some important numerical which are based on De-Broglie wavelength and Heisenberg Uncertainty Principal. In my last couple of video lecture, we talked the topic, and the topic was De-Broglie wavelength and Heisenberg Uncertainty Principal. So here we will see one important numerical which is directly related with De-Broglie, and then it is Heisenberg Uncertainty Principal. So directly we are going to discuss one question, that is problem 1. Calculate the mass of photon with wavelength 3.3 angstrom. So students, here wavelength is given in angstrom. That means you have to convert this angstrom to meter. Very important, because wavelength means lambda, and lambda is always in meter. So first of all, forget about all these things. Just mention the given term. So given is lambda, wavelength 3.3 angstrom, and as I converted this angstrom to the meter, means 3.3 10 to the power minus 10 meter. Now angstrom is nothing but it is meter, and some terms we know that that is speed of light, speed of photon, or velocity of light, velocity of photon. It is what? 3 into 10 to the power 8 meter per second. We know this number, we know this quantity, and the next one is Planck's constant, that is h, and it is what? 6.6 10 to the power minus 34 joule second, and the term joule is nothing but it is kilogram meter square upon second square. So it's all about the given data. And students, suppose you are going to solve the question which is based on De-Broglie and Heisenberg, you will come to know at the time of exam directly, no problem. So at that time you have to fix this amount. Number one, speed of photon, you have to put this amount in given data, and next is Planck's constant, you have to also write in that segment. Now next segment is asked. What is asked here? It is calculate the mass of photon, means we have to calculate the mass of photon in kilogram, and mass is nothing but m. So what I will do, I will use the formula which is belongs to De-Broglie wavelength, lambda equal to h upon mv, or because I have to calculate this mass, that's why I converted this formula into next part, that is h upon lambda v. Put the value of h, lambda and v, and when you further you will solve it, you will get only mass which is in kilogram. So you can check how I done this. Very common numerical, very simple numerical, very simple calculation, this one directly. So when you will solve this, you will check, you can check kilogram it will be here. Next is mass to mass cancel, second to second will be cancelled with all respect, and meter to meter will be, it means only thing will be there, that is kilogram, right? So answer will be 6.6 into 10 to the power minus 33 kilogram. This is the final answer for this question. Means what I have to do, I have to write in 3 segments. Number 1 given, number 2 asked, and number 2 what formula I will use, or what formula I am going to use for that particular numerical. See here, next question. Heisenberg Uncertainty Principal. A golf ball has a mass of 40 gram. Students, mass in gram, that means you have to convert this in kilogram, right? And speed, if what? 45 meter per second. If the speed can be measured within accuracy 2%, means 2 by 100. What is the meaning of 2%? 2 by 100. Meaning of 2% means what? 2 by 100. Next, 45 meter per second is the speed, and he is asking about the uncertainty principle, uncertainty in position, correct? In the Heisenberg Uncertainty Principle. Again, design given, mass is given 40 gram, and I converted this gram into kilogram. 40 into 10 to the power minus 3 kilogram. Speed 45 meter per second with accuracy 2%, means you have to multiply this term 2% with what? The value which is speed, and speed is 45. Now next is, I already fixed amount, Planck's constant. I told you, you have to mention this one. 6.6 10 to the power minus 34 kilogram meter square second square into second. It is what? It is nothing but joule. What is asked? Uncertainty in the position, means directly you will use formula. Next step is formula. if you will do your numerical portion such like given, asked in the formula manner, means you are eligible to earn step marking rather than you are solving the directly you are mentioning the answer. Means what? You can earn step mark by simply you can do simply this thing, right? Formula delta x m delta v h upon 4 pi. What is this? It is Heisenberg uncertainty principle. So in this question we have to calculate delta x. Delta x means what? Uncertainty in position. So next term will be crossly changed to that side, 4 pi m delta v. Put the value of 4 pi h m in gram and n in m in kilogram, and that is 45 meter per second multiplied by 2 by 100, which is accuracy 2%, which is what? It is velocity. When you will solve, you will get this data. So it's all about the approach of numerical, how we can solve the numerical, how we can frame the numerical, which is asking by the examiner in the question. So the steps are what? Given, asked and formula. Given, asked and formula. Suppose somehow your calculation is little wrong, then no issues, he will give almost full mark about your steps, about your the topic, that is given, asked and formula. Remember 3 things, students: given, asked and formula. So for next video lecture we will take some important topic, we will discuss and we will meet again. So till then, thank you, thanks a lot.